Okay, now we get into a different type of question. It says, what is the radius of a quarter circle with an area of 81 pi over 16? Well, first of all, let's notice that it's not a decimal. It has pi in the answer. And they're asking for the radius of a quarter circle with an area. So let's just write down the area stuff. So area equals pi times the radius squared. And that's actually what they're asking. They're like, what is the radius? We don't know the radius. But they did say it was a quarter circle, so it's 1/4 of the whole thing. So you might be like, well, how come you use degrees here and you don't here? Well, the degrees give us the proportion that we need. So we have 270 out of 360 degrees here, but here we don't have degrees, but we do know that it's just 1/4 of a circle. So it's kind of the same idea. It gives us the proportion. So they did give us the area. It's 81 pi over 16. And we still have 1/4 pi times the radius squared. And now we're just going to solve this. Now, you might just want to grab a calculator and be like, hey, let's just go ahead and figure it out. I'm going to go ahead and tell you, we can do this one without a calculator, and it's probably easier if we don't. We would avoid a lot of decimals that would be very unnecessary. So lots of stuff we can do here. Some people will be like, divide by 1/4 pi. I hear you. I'm not. I'm going to divide by pi. I'm going to stretch this out just a few steps so we can kind of gain a mathematical understanding of what's going on. And when we do, we have 81 over 16 equals 1/4 r squared. And now we can divide by 1/4. Nobody likes to divide by fractions. Instead, we'll multiply by 4, and we'll cancel those. So r squared equals, and we'll cancel this with that, and that gives us 4. So 81 over 4. So 4 goes into 16 4 times, right? And so, again, if you grab a calculator, go for it. But here, this is faster. Square root this, square root this. And when you square root a fraction, you just square root the top and you square root the bottom. So it's 9 halves. I'm going to call it 4 1/2. I'm going to say 3 1/2. I'm going to call it 4.5. And they did not give us units, so I don't know if it's centimeters or inches or whatever. But I do know that the radius is 4 1/2, which means if I was to plug it back in, I would get that as an answer. Okay? A little anticlimactic, but we figured it out. Now it says, what is the angle measurement of an arc that measures 15 pi with a radius of 6? Okay, now there are no square units here. They said the arc measures such and such. So now we're dealing with this. Okay, now here's the thing. I don't know how much of the circle I have. And I'm wanting the angle measurement. I'm wanting to know how much out of 360 degrees. I'm going to call it x. Call it a, call it x, call it whatever you want. And so then I'll have 2 times pi times my radius, which is 6. And I actually do know my circumference. So I'm going to keep going a little bit more, and we're going to say, well, my circumference, which is not really my circumference, okay? It's my arc length. This is arc length, which is why I'm using this formula instead. It's going to be 1.5 pi equals x over 360. And now let's clean some of this up. Well, we have 2 times pi times 6. Well, that's 12 pi. All right, so again, a step that you could leave out, and I'm okay with that, but I'm going to just sort of show it. I'm going to divide by pi. It just keeps the pi's from floating around. And I have 1.5 equals, there's a lot of ways to clean this up. I'm going to kind of, well, I don't know. Let's not complicate things. Let's call it x over 360 and then times 12. Now, you can make it 12x over 360. That's what I was about to do. I choose not to. Let's multiply by 360. So we're going to multiply by 360, which wipes those out, and multiply by 360 here. So 360 times 1.5 would be 360 plus 180, which would give me 540. So 540 equals x times 12. That's 12x. And again, lots of ways you can go about this. We'll divide by 12. And x equals, let's see, how many times does 12 go into 540? It goes in 4... I'm trying to do this without a calculator. Awkward blank stare, right? 540 divided by 12. Yeah, I'm grabbing a calculator. 4T5. Okay. That's what I thought. I just sort of thought it. Anyway, they didn't give me any units here. They weren't saying it was inches or centimeters or whatever. So it's 45. There we go. 40, oh, wait. Degrees. Sorry. Having a brain fart, massive brain fart. I couldn't divide 12 into 540, and then I didn't know what measurement to use. Well, I'm finding the angle measurement, and that's why I know I'd use degrees, right? Okay, so now we get to one that's a little trickier because they're actually going to ask volume. So let's just kind of do it. A circular cake has slices cut from the center that each measure 20. Well, I say circular because it's, well, circular, but you've seen a cake. It's really, circular, it's really a prism. See? Okay. There we go. So that is what my cake looks like. And the diameter of the cake is 9 inches, and its height is 7. So this is 7. And the diameter is 9, which really means the diameter is 4.5. And so then how many cubic inches of cake are in each slice? I don't know. Hold up just a second. Cubic inches? Now, why am I not dealing with area and arc length and like what's the deal here? Okay, let's look. Let's just look at the top of the cake for just a second. If I'm just staring right down at the top of the cake, then I would say, well, that's 4.5. And I'm ignoring the height because I'm just looking at the top of the cake. And that is 20 degrees. So let's go ahead and find that area. So we're going to do the area, which would be 20 out of 360 times pi times the radius squared. And when we do that, we're going to find the area of the top. Now, why are we doing that? Okay, well, you'll see. You'll see. 20 over 360 times pi times 4.5 squared. So we have 3.53 square inches of cake on the top. Okay, now they didn't ask for square inches, they asked for cubic inches, which means this. If I wanted to know, and let's just kind of take this problem out of context for a second. If I wanted to know the volume of the whole cake, I would find the volume of the cylinder, and the volume of a cylinder is this ridiculousness right here. It's going to be pi r squared times the height. Okay, so like if I wanted to know the volume, I'd do this formula for the whole thing. Well, I don't want to know the whole thing. I just want to know the volume of a slice. So I could have put 20 divided by 360 in front of that whole thing. Or I could just go ahead and deal with that, which I've already done, and then find the volume, which would be 7 times that. So 7 times that right there is going to give me 24.74 cubic inches of cake. Now, that might have been a little bit confusing, and I hope it wasn't, but let's do it again. Let's do it a different way. So if you're not following this jump from here to here where I multiplied by 7, where I basically threw in an extra multiplication by an inch, which gave me cubic inches, then we can do it another way. So here's the other way, and that's going to be pi r squared h. And it's exactly what we just did, but we don't have the whole cake. We just have 20 out of 360. So this is the second way of doing it. You don't have to do it this way. So 20 over 360 times pi times the radius squared times 7. And in the end, we're going to get 24.74 cubic inches of cake. It's a good chunk of cake. Okay, now it gets a little crazy. If the cake is frosted on the top and on the sides, how many square inches? Whoa, we're back to area now. Okay, so square inches of frosting are on each slice of cake. Whoa. Okay, so I'm going to attempt to draw this. And let me say this too. When you put on icing, usually there is a thickness to it. We're just going to pretend like it's perfectly flat, and we just want to know the area. Okay, so here is a slice of cake. Okay, I want to know how much frosting is on it. I'm having a hard time drawing around the edge there. I want to know how much frosting is on it. Let's make it red frosting to make it stand out. So I need to know the area of the top. Stop right there. Let's just stop right there and find the area of the top. Don't go any further. So I'm just going to write down in words what's about to happen. So area of the top. And that's going to tell me how many square inches of frosting are on the top. We haven't talked about the side, okay, but we'll get that. Now, let's not do that. That's where you cut out of the middle of the cake, right? So when you sliced it and like here's the cake and then here's the icing and there's your icing. So the area of the top is, oh, I've already found it. So I'm not going to do all that work again. That would be the area if I was looking straight down at it. It would be 3.53 square inches. Okay, now let's also find the area of the side. We'll also color it red. Can make it green, make it a Christmas cake. Is that even a thing? Okay, so the area of the side, and this actually is going to be a little bit trickier. So area of the side, and that would be, well, let's figure it out. I think if we were to look at this piece of cake, you got this like rounded out side, and if you could unfold it, you'd have a rectangle, and this rectangle would be this rectangle right around here. Let's kind of draw it right there. I'm looking at my cake, and I somehow unfolded the frosting on the edge. It's 7 inches high, right? Well, how long is that? How long is that length right there? Well, I can't tell you because I don't know, but I can easily find it because what they really need is the arc length. So let's do arc length and then do it times 7. So the arc length in this case would be, well, 20 out of 360 times 2 times pi times the radius. Okay, and that's just this distance right here. And then we'll multiply it by 7. So whatever I get when I do that. So 20 over 360 times 2 times pi times 4.5 times 7. And I got 10.9955, which really is, let's call that 11. And that is, oddly enough, rounded off, 11 square inches. So I have 11 square inches of frosting here, 3.53 square inches of frosting here. So I'm going to add those two together. And I'm not going to put a plus sign right here because that's going to be confusing what that equals. But basically, I'm going to do 3.53 plus 11. So it's going to be 14.53 square inches of frosting. So again, found the area of the top, found the area of the side, which was like a rectangle. And that was arc length times height.